Hi everyone. We're going to determine whether the series is absolutely convergent, conditionally convergent, or divergent. So the first thing we're going to do is use the alternating series test to determine if our series is convergent. So if you look at this, I'm going to let b sub n equal 1 divided by 5n plus 1, because I can pull this out. And I'm making it look like this formula here. And this is positive. And that is for n is greater than or equal to 0. All right, now let's look and see if it satisfies these two conditions. So I'm just going to write out some terms. If I let n equal 0, we get 1. If I let n equal 1, we get 1 divided by 6. If I let n equal 2, I get 1 divided by 11. So basically what this says is that our b sub n plus 1 is smaller than our b sub n. That means this is decreasing for all n. So this checks out. And now we have to take the limit. So we take the limit of, as n approaches infinity, of 1 divided by 5n plus 1. Now, as this number gets larger and larger, this is going to go to 0. So that was an easy one that satisfies. So this is convergent. But we really need to check for absolute convergence. So what I'm going to do is use the limit comparison test and test it to a sub n equals 1 divided by n. This is your harmonic series and it's divergent. So if this test, if they're the same, then it'll be divergent. So basically, if C is a finite number and C is positive, then they both either converge or both diverge. So if we get a positive number here, then they're both going to diverge because our harmonic series is divergent. All right. Let's see. Put that in N. All right. So let's do our limit comparison test. So that means we're going to write this as the limit as n approaches infinity of 1 divided by n divided by 1 divided by 5n plus 1. So basically I can just move this up here, and this is going to equal the limit as n approaches infinity, and this is going to be 5n plus 1 divided by n. So let's go ahead and write this, the limit as n approaches infinity, and divide each piece by n. So that would give me 5 plus 1 divided by n divided by 1. Applying the infinity, this goes to 0, so we get 5. Now 5 is positive. Since it is positive, it means that both series converge or diverge. But we know that this series, the harmonic series, already diverges. So that means it diverges. Our alternating series test said it converged. Our limit comparison test said it diverged. So that means this is called conditionally convergent. And that's it. Thank you. Have a nice day. Bye-bye.